So yesterday we started chapter 5, section 4. We talked about solving exponential equations. We did examples. A lot of it was the same as what we've been doing all along. And now what we're going to do is learn how to solve log equations. So what we're going to do, just like before, if there's only one log, you're going to put it into the equation into exponential form, and then you can solve it. Same thing, if there's only one ln, you can convert it to log e and then put it into exponential form. If you have one log on either side and it's got the same base, you could use that one-to-one property, cancel the logs, and then solve what remains. If there's multiple logs in the problem, then you're going to condense it using those properties, the product, the quotient, the power property, and then you're going to use one-to-one or change it to exponential form. Remember that log expressions, whatever you're taking the log of, have to be positive numbers. Okay, so if after you solve a log equation and you plug it back in, if it makes it a negative number or a 0, then you would throw that solution out. So when we're solving the log equations, you need to check. So let's try some examples. So this is the scenario where we only have an ln here. So what we can do is go ahead and put this into exponential and then solve it using our calculator. Remember, the base for the natural log is an e. So you can do two things here. You could either say, well, I'm going to make it log base e of x equals 3, and then turn it into exponential, and then use your Bay trick, BAE, and you would be doing e to the third power equals x. So you'd hit your E button that has the little place to put the exponent in there. And once you do that, and we're going to round or truncate to 3 places. So once we do this, we get second E, put a 3, hit enter, and the number I get is going to be 20.08553692. Truncated, again, remember you just chop off anything that's beyond. So the truncated answer is 20.085, but the rounded answer would go up and it would be 20.086. So this would be rounded, and again, that's what you're doing in WebAssign. Example 14 is exactly the same. There's only one ln, so I'm going to go ahead and replace it with a log, and then I can, or again, if you just know that there is an e here, BAE, and you would do e to the second power equals x. Take out your calculator. Again, raise e to the second power, and we would get 7.389056099. Again, we're going to truncate, so we're going to chop off everything here. However, both the truncated and the rounded answer are the same, 7.389, because the 9 would look at the 0 and it would tell the 9 to stay the same. The next one, we can just use our one-to-one property, and we can just cancel the logs because it's exactly the same on both sides. So here I could just cancel log base 3, and now I solve what remains. 5x minus 1 equals x plus 7. I need to get my x's to one side of the equation, so I'll subtract x. 4x minus 1 equals 7. I'll add 1. 4x equals 8. Divide by 4. And x equals 2. Now I need to do a quick visual on this and make sure that this 2, when I put it into this parenthesis or this one, if it makes either of them a negative number or a 0, then I would throw away the 2 and say it would be no solution. But you can already see that 5 times 2 is 10, minus 1 is 9. Same thing here. 2 plus 7 is 9. It doesn't make it negative or a 0. So x equals 2 is a good answer here. The next one, notice there are 3 different log base 6s. This is the scenario where you need to condense. So I need to condense the left side. Notice the subtraction sign here. So what we need to do is turn this into a division. So let's go ahead and condense the left side, log base 6, 3x plus 14 over 5. And then this side stays the same, nothing to condense. Now that I've condensed it, now I can use the one-to-one property, cancel out the log base 6, and I solve what remains. 3x plus 14 over 5 equals 2x. I'm going to go ahead and solve this as a proportion. You could also just multiply both sides by 5, get rid of that denominator, but you could do this as a proportion and cross multiply. So I could do 5 times 2x and 3x plus 4 times 1. So here I get 10x equals 3x plus 14. I need to move the 3 over. Get my x's on one side of the equation. Divide by 7. And x equals 2. Remember, we need to check. So if I go back up here and plug in 2, I would get 3 times 2 plus 14. 6 plus 14 is 20. That one's okay. And then here, 2 times 2 is 4. Nothing was negative, so I'm good. So just remember, the number that's here can never be negative or 0. So if you get a negative number, then you would throw it away and you would say no solution if there was only one. Usually when you get an x equals a positive number, it's not going to be a problem. Okay? But you can always just double check that. Everybody good on this slide? Let's try number 17. Same thing here. We have a log on the left and a log base 2 on the right. We're going to use our one-to-one property. Just cancel out that log base 2 and then set what remains equal to each other. Move our x's together. And then we'll move our constants together. And we get x equals 7. And again, double check it, do a quick 7 plus 4, that's 11, it's good. 2 times 7 minus 3, 14 minus 3 gives me 11. Either way, neither of them are negative, so x equals 7 is a good answer. Number 18, we need to use our condense first because we've got 3 different logs going on. Do not make the mistake and think that you can just cancel all these out. Okay, you can only cancel the same number of logs. So if there's one on the left and one on the right, you can do that. I can't just go through here and cancel all those logs. I have to condense this. This is a subtraction sign. So this tells me I'm going to be using my quotient property. So I'm going to condense that left side and make this log of 4x over 12 plus x. Set that equal to log of 2. Now I can use my one-to-one property and now cancel out the logs and solve what remains. 4x over 12 plus x equals 2. And again, I can solve this as a proportion. I could add a 1 underneath, and then I can cross multiply. So I would be doing the 2 times the 12 plus x, as well as the 4x times 1. So once I cross multiply here, I end up with 4x, or let's let's get 4x equals, and I'm multiplying 2 times 12, 24, plus 2 times x, 2x. Move my x's together. 2x equals 24, divide by 2, and x equals 12. Again, we would double check, make sure that if we would get a negative value, but when I put it up here, 4 times 12 is 48, that's good, and then 12 plus 12, 24. It doesn't make anything negative, so x equals 12 is a good answer. Let's try the next one. Number 19. Again, we need to get this where the ln x is all by itself. So let's go ahead and subtract the 5. And we get 2 ln x equals -1. Divide by 2. ln x equals -1/2. And now I'll turn it into exponential form. Remember, the natural log has this assumed base e. So I'm going to put it into exponential, and it's going to become e to the -1/2 power equals x. And now it's just a straight calculator question. You'll hit that e, raise it to the -1/2 power, and we are going to get .6065306.597, and then truncated, you're just going to chop off. So the truncated answer is 0.606, but the rounded answer, the 6 would look at the 5 and it would go up. So this would be the rounded answer, which is what you're doing in WebAssign. We're going to do exactly the same thing in number 20. We're going to isolate that ln x first, and then we'll turn it into exponential, and then it's a calculator question. Pretty good on 19. Let's try 20. So again, I'm going to move the 7 first. We're working backwards of order of operations. We always add or subtract first when we're solving. And now I'm left with 3 ln x equals -2. Divide by 3. ln x is equal to -2/3. I'll now turn it into exponential because I cannot solve it in this form. So I get e to the -2/3 power equals x. Take out your calculator, find your e button that raises it to a power, put in -2/3. If you're going to do it, if you don't have the option of putting it in as a fraction, you would use the fraction bar, the division sign. So e for those of you who have the graphing calculator, you can hit the alpha and the y equals button, and it gives you the option of entering it as a fraction. So this would give me 0.513417119. If I truncate, I would chop off from the 4 over. And again, the 3 would look at the 4. So rounded or truncated, it's the same answer. 0.513. Number 21. Again, I want to get just the log by itself, so I'm going to divide both sides by 2. So log base 5 of 3x equals 2. I cannot solve this the way it's written in log form. So now I'm going to put it into exponential. So again, if you want to do your matrix, this is the base, answer, exponent. So I'm going to be doing 5 squared equals 3x. 5 squared is 25 equals 3x. And then divide by 3. And x equals 25 over 3. And even if I plug that in, it still makes it positive. Doesn't give me a negative number. We're going to do exactly the same thing on number 22. I want to get rid of that 3 that's in front. So I'm going to divide both sides by 3. Log base 4 of 6x equals 3. I'm going to go ahead and turn it into exponential form. So 4 to the third power equals 6x. 4 to the third power is 64. Divide by 6. And x equals 64 over 6. I need to reduce to 32 over 3. And again, if I plug it in, it's positive. It's not going to make anything negative. So if you can reduce, definitely always reduce. Number 23. I'm going to condense the left side. Then it'll turn into a log form. And then from there, I can see what I've got. I can turn it into possibly an exponential form. So let's go ahead and condense. The plus sign tells me that this is going to be the product rule. So I'm going to do log 5x times x minus 1 equals 2. I know that because there's no little subscript here, this has an assumed 10. This is in log form. I'm going to go ahead and distribute this. And I get log base 10. And this turns into 5x squared minus 5x equals 2. This is spelling bee. I'm going to turn it into exponential form. So I'm going to do 10 squared equals 5x squared minus 5x. I'm going to square the 10. And now I'm going to turn it into a trinomial that I can factor by subtracting the 100. 5x squared minus 5x minus 100 equals 0. First thing I'm going to do is factor out a GCF of 5. So I'm left with x squared minus x minus 20. And now I'm looking for the factors of negative 20 that give me negative 1. And that's going to be x minus 5 and x plus 4. Now I need to solve for x, setting each piece equal to 0. Setting this equal to 0 is nonsense. We don't need to worry about that one, but we do need to do these two. This one gives me x equals positive 5. This gives me x equals negative 4. I need to check this. I need to make sure that these answers aren't going to make my original problem negative. So remember, your original problem was log of 5x plus log of x minus 1 equals 2. So if I put in a 5 here, 5 times 5 is 25. That one's good. And then 5 minus 1 is 4. So this one checks. But let's try the negative 4. If I do 5 times negative 4, I get negative 20. It's making this one negative. I don't even need to look at the other one. It's going to make the other one negative as well. So we're going to throw away that answer. So the only solution here is x equals 5. Because again, we do not want it to be negative. Let's try 25. Or I'm sorry, 24. Again, we're going to condense. It's a plus sign, so again, product. So log of x times x minus 9 equals 1. I'm going to distribute. X squared minus 9x equals 1. Now, I'm going to show you two different ways to do this. I'm going to go ahead and just do it the same way I did before. Remember, right here assumed is a little 10. So I'm going to turn it into exponential. So 10 to the first equals x squared minus 9x. I'm going to move the 10. 0 equals x squared minus 9x minus 10. I need to factor this. Factors a negative 10 that give me negative 9. And that's going to be x minus 10 and x plus 1. Set each equal to 0. I get x equals positive 10 and x equals negative 1. Remember, you need to check. Just plugging in to the first one, this one, let's see, just taking this x minus this x equals negative 1 and putting a negative 1 right here, it makes that negative. So this one's out. And then if you plug in the 10 works on both. Because this just becomes a 10, this becomes 10 minus 1, or 10 minus 9, and you get 1. So it doesn't make it negative. So the only answer here is x equals 10. Now, the other day when we played the GIM kit, you had questions that said, what is log of 10? And you knew that that should equal a 1. Because remember what we're doing here, this has the assumed 10. 10 to the first equals 10. If you had log of 100, that's going to equal 2. So what you could have also done is after you condense here, you could have also replaced this 1 with what it equals, which is log 10. And then you could have used the one-to-one property. So you could have also condensed it. So you would have condensed the left like you did and got x times x minus 9. But now in taking out the 1, you could put over here log of 10. Then you could use your one-to-one property and cancel that, and then just solve what remains. Distribute. You're still going to have to factor, and then it would go down to here, and you would solve it the rest of the way. So if you memorize that the log of 10 equals 1, or log of 100 is 2, or log of 1,000 is 3, you can also substitute in for that if you're trying to get both sides to have a log. Let's try the next one. I'm going to go ahead and change this one to a log of x, and I'm going to raise it to the 1/2 power. I'm going to change the root to a rational exponent. And now to get rid of that fraction, I can square both sides. And now I'm left with log of x squared equals log of x. Now this is sort of like what we had to do at the beginning of the year. So what we're going to do is we're going to move this log x to the other side. So we get log x squared minus log x equals 0. I'm going to factor out a GCF. I'm going to factor out a log x. And then I'm left with log x minus 1 equals 0. And now I can set each of my factors equal to 0. So log x equals 0. Log x minus 1 equals 0. I can put them into exponential form now. Remember that each of these has a little assumed base 10. So we're doing 10 to the 0 power equals x. So this tells me x equals 1. Over here, 10 to the 0 power equals x minus 1. I get 1 equals x minus 1. Actually, wait, let me go back. Sorry, I need to isolate the log x first. That'll be better. I'm going to move the 1. Log x equals negative 1. Assume a little 10. 10 to the negative 1 equals x. I'm up, adding 1, thank you. And then I get 10 to the first, so x equals 10. Thank you, good catch. All right, neither of these make it negative, so we're good on both of these. Yes?
How'd you get the log x minus 1?
So I took this and set this one equal to 0, and then I took this one and set it equal to 0.
Oh, no, like how'd you get the log x squared to log x minus 1?
Oh, this right here. So what I did was I turned the square root into a fraction exponent. Then to get rid of the fraction, I raised both sides to the second power, which canceled that. And then now I need to get my x's together so I could solve this. So I moved this log to the other side, and then it became this statement. And then I factored out a GCF of log of x. So when I divide this one by log of x and this one by log of x, this is what remained. And then you set both factors equal to 0. So sort of like we did at the beginning of the year. Let's do 4 more examples and we're done. All right, so what I'm going to do is notice that only 2 of my terms here have a log in front. So what I'm going to do is get all the logs to one side, and then I'm going to condense, and then I can turn it into exponential. So let me move this log to the other side. So now I have log of 11x plus 9 minus log of x plus 4 equals 3. I'm now going to use my property, my quotient property, to condense this. So I only get one log word. And I get 11x plus 9 over x plus 4. Now it's in log form. I can now convert it to exponential. Remember, when there's no number here, this is a 10. So it's going to be 10 to the third is equal to 11x plus 9 over x plus 4. Again, I could treat this as a proportion. I could put a 1 here. I'm actually going to figure out what 10 to the third power is, and that's going to be 1,000. And now I'm going to cross multiply. So I'm going to multiply the 1,000 times the x plus 4, and then the 11x plus 9 times 1. So I'm going to go ahead and cross multiply here, and I end up with 1,000x plus 4,000 is equal to 11x plus 9. I need to move my x's together, and I get 989x plus 4,000 equals 9. Then I need to move the 4,000 to the other side. X is on one side, numbers on the other. 989x is equal to negative 3,991. I'm going to divide that by 989. And I get x is equal to, let's see, 3,991. I get negative 4.035389282. And I could truncate this and round this. So truncated, negative 4.035. So truncated and rounded is the same. However, remember we need to check. So if I go back to the beginning, just putting it into this one, it's way over here. Just putting x plus 4, putting negative 4.035 plus 4, you can see how that will make this negative. I would get a negative 0.035. So this is no solution. That one was a lot, but again, just basic stuff. The next one is really what we did yesterday. This one is in exponential form. This was the one that was sort of similar to the one that was really long. So remember, when it's in, both sides are in exponential form, what we can do is add an ln to both sides. So let me see, let me go over here where I got lots of room. So I'm gonna put in ln in front, ln 6 raised to the x minus 3 equals ln 3 raised to the 4x plus 1. Remember, this is where we're gonna take and use our power property, and we're gonna move this exponent to the front. So this becomes x minus 3 times ln of 6 for x plus 1 times ln of 3. We need to distribute. So I'm going to distribute the x to the ln 6 and the negative 3. Then I'm going to do the same thing on the right side. Distribute first the 4x and then the 1. Now I need to get my x's together, and then I'm going to move my constants together. So I'm going to go ahead, and it doesn't matter which way you move it. I'm going to go ahead and move the 4x to the left. X times ln 6 minus 4x ln 3 minus 3 ln 6 equals ln 3. So this moved to the other side. Now I need to move this one to the other side. It's gone from here. And now I'm left with x ln 6, 4x ln 3 plus 3 ln 6. Now I have to pull out a GCF of x from the left side. And now I'm going to divide both sides by ln 6 minus 4 ln 3. And this is where your calculator comes in. And again, when you're doing it, let me go ahead and do this. Here's how I recommend you do this. I recommend that you're going to take the numerator, put it in parentheses, close the parentheses, hit enter, and then you're going to hit divide, and then parentheses again, and you'll do the denominator, and then you're going to hit enter. So let's see what we get here in the stages. So we would get so I'm going to do parentheses, ln3 plus 3 ln6, close the parentheses, hit enter. You should be getting 6.473890696. Leave that on your calculator. Then hit divided by, open a parentheses, ln6 minus 4 ln3, close the parentheses, hit enter, negative 2.48738477.5, truncated, and we end up with x equals negative 2.847. So truncated and rounded is going to give us the same answer. We don't need to check this because the original problem was exponential. What we could do here is we can use our product property, or our power property, and I can move these to the front. X ln minus 2 ln equals 4 ln. And if you recall back from the other day, ln equals 1. So you could substitute and put x times 1 minus 2 times 1 equals 4 times 1 and get x minus 2 equals 4. Add 2 and x equals 6. Just remember that you would have to first apply the power property and swing that around the front, and then you could multiply it. All right, let's try the last one. I'm going to change this square root into a fraction exponent. So I'm going to turn this into, actually, let's just go ahead and turn it into exponential because it's in log. Everything looks good. So BAE. So 2 raised to the 3/2 power equals 2x squared under the square root. So let's go ahead and simplify this. Let's turn this now into a fraction exponent. And now I can get rid of the fraction exponent by squaring both sides. Notice squaring this cancels this, squaring this cancels the denominator. So now I'm just left with 2 cubed equals 2x squared. 2 cubed is 8. Divide by 2. 4 equals x squared. Square root both sides. X is equal to plus and minus 2. And let's go ahead and double check it. So what we're plugging it into is 2x squared. When I plug in a negative into an x squared, it becomes positive. So both answers actually work here. And that's it. That is the end of chapter 5. Here, I think I flipped my numbers on this one. This final answer, I wrote it backwards. This should actually be the 4 and the 8 need to be flipped. This is actually negative 2.4873 and so on. If you truncate it, it's going to be negative 2.487. And if you round it, it's the same. So I actually flipped those numbers. So this one is a correction here. So this was the answer to number 27. So when I wrote down my numbers, I wrote them backwards.